Hello and welcome back to my YouTube channel Electrical Hub. First, I would like to thank you for your support. Here we are going to discuss about the power factor improvement and its benefit. Power factor can be improved in the industry by using capacitor bank. Here we are going to discuss how loading of transformer gets reduced by using capacitor bank. Second, what are the cost benefits of power factor improvement? Thirdly, we will also discuss about selection and the location of capacitor banks or capacitor and its advantages and disadvantages. Finally, we will discuss about the reduction in the distribution loss due to the improvement of power factor. In the industry, most of the loads are inductive loads, and inductive loads have two types of power. One is the active power, another is reactive power. Active power is the power required to do the active work, and the reactive power is required to maintain the electromagnetic field. Loading of transformer. For example, let us take 1.5 MVA transformer. Here, kilowatt is 900, kVAR is 800, and kVA is 1200. So, the loading of the transformer is 80%. Now, if we will buy a capacitor bank of 100 kVAR, so the new kVAR will be 700. Accordingly, the new kVA will be 1130. So, the loading of the transformer will get reduced to 76%. This is just for an example. We will later discuss about the selection of the capacitor bank, and in that we will completely discuss how we are going to reduce the loading of the transformer. First, let us discuss about the advantages of capacitor bank. First, reactive power reduced, so the total current in the system also get reduced. As the total current in the system get reduced, so obviously the I square R loss also get reduced. Third, the voltage is improved at the load end. And finally, the kVA loading of the transformer get reduced. A high power factor can help in utilizing the full capacity of electrical systems. Use of the capacitor bank also have a lot of cost benefit. For example, first, KVA charges in the utility bill get reduced. So, whatever the KVA we are taking from the grid get reduced. And as the current gets reduced due to the reduction of the KVA, so distribution losses also get reduced. Thirdly, it eliminates the penalty charges for operating at low power factor. It also reduces the direct investment on transformer or switchgear because due to the improved power factor we can use it at its optimum capacity. So here comes the selection of capacitor bank. How will you evaluate how much KVR rating of the capacitor bank is required at your section? So first you determine the kilowatt. So and the existing power factor. According to the formula, if you put kilowatt multiplied by tan of cos inverse PF1, that is existing power factor minus tan of cos inverse improved power factor, then you will get the desired KVR rating required to improve the desired power factor. Location of capacitor bank. Maximum benefit of capacitor is derived by locating capacitor as close as possible to the load. But while doing this, if there is some advantages, there are also some disadvantages. First, going with the advantages, it increases the load capabilities of the distribution system. It can be switched on with the equipment and switched off with the equipment. Better voltage regulation, capacitor sizing is simplified, and capacitors are coupled with the equipment and move with the equipment if rearrangement done. But the disadvantages is that small capacitor cost per kVr is larger than a bigger unit. Secondly, if the capacitor are placed with a equipment group, for example, in a MCC, if the capacitor is fixed with each MCC, then the advantages are that in increases the load capabilities of the services, reduce the material cost relative to the first one, means capacitor with each piece of the equipment. It also reduces the installation cost. But switching here may be required because in one MCC It is not confirmed that all the motor will run at the same time. So it may happen that sometime 10 or 15 motors are running and sometime only the 5 motors are running. So here will be a requirement of switching. Now, third, the capacitor at the main service. Low material installation cost. But disadvantages are switching will be required, do not improve the load capabilities of the distribution system. Reduction in distribution loss. Reduction in distribution loss in kilowatt hour when Talent power factor is raised from PF1 to PF2 will be proportional to 1 minus PF1 by PF2 whole square multiplied by 100. Thank you. Please like, share, and subscribe to your friends. Thank you.